Well, it's a really great question. And I guess it's encapsulated by what I was trying to say in the whole of the talk, which is that however well we feed a child, if we're trying to do that against a very damaging background of a lot of contamination from the environment, then that optimal feed, the child won't be able to respond to that food, however good it is. And I talked through some of the mechanisms by which that might occur. Predominantly this issue of gut damage. So the pathogens from the environment, some of the other contaminants from the environment seem to cause a persistent damage to the gut, which we call environmental enteric disease. And this, if you look at a child, if you take a biopsy of the child and do the histology of that, what you see is that the villi that are usually lovely finger-like, large surface area to absorb all the nutrients have been damaged. They've been cut short. So the child's ability to absorb nutrients is reduced, and also it's spending a lot of energy and nutrients on the inflammatory responses as it tries to sort out the adverse effects on the gut mucosa. So I think that would be one of the key things. The next question we ask is, well, why does this occur in such children? And that comes round to many of the issues that we've spoken about in today's session, which is that the environment is so contaminated. And contaminated to such an extent that even if we try to dampen that down with some of our interventions, we find that that's really very difficult indeed. Yeah, so some very interesting questions there around the composition of breast milk and whether indeed that is ideal for the child. So I would certainly subscribe to the view that breast milk is the ideal food for the young baby. To me, there's absolutely no doubt about that. But that doesn't, as Professor Allen demonstrated in her presentation, that isn't the same as saying that breast milk is perfect. And if a mother is undernourished, then her milk can be deficient in several nutrients. The water-soluble micronutrients tend to reflect really what's inside the mother. So there's a strong relationship between what's in the mother's body and her plasma and what's in the milk. Some of the nutrients aren't related very clearly to the maternal nutritional status. And then with some of the other nutrients, we have some strange things going on. For instance, we've known forever that there's very little iron in human breast milk. And iron is an issue of great interest to me. We would believe very strongly that iron is necessary for brain development. So you ask the question, well, why this perfectly evolved form of feeding has so little iron? And we think that the answer is because iron feeds bacteria. So evolution has been smart enough to say, let's not give too much iron to our babies. My view around that is that may now that we hopefully have moved from a situation where babies aren't dying by the hundreds of thousands in very young childhood, then we should be able to ask whether maybe we can give more iron, we should be giving more iron in order to optimize their brain. So evolution has always been working on a compromise. Don't give too much iron because the children will die, but now we've moved beyond that. So the evolution, if you like, has become redundant, and there may well be a case for giving more iron. Goodness me, you're testing me with a question that we've tested ourselves with for several decades now. We've been grappling with this issue. Should we intervene in the kids? Should we intervene during pregnancy? Should we intervene in early pregnancy, late pregnancy? And now our interest is really focusing on should we intervene before pregnancy, before conception? And I think that is going to be a very important time point. But at the end of the day, we need to intervene at all of these periods. And what we're really moving towards is the view that you cannot sort a baby out by nutrition alone. You can't sort it out by nutrition alone at any particular time point. Everything has to be right. We've got to clean up the environment. We've got to educate the mums how best to feed their children. And once everything is right, which incidentally it is in so many wealthy people in Africa, wealthier, better educated people in Africa, their kids grow beautifully and their cognitive development is wonderful and they do fantastically at school. So there is this great hope for the future, but we've got to pull everything together. And we use this phrase, combining nutrition specific with nutrition sensitive interventions. And that's in a way what we were trying to say today. It's not just about nutrition, we've got to get it all right. I think the first thing to say about nutrition and the baby's epigenome is that we're at a very exciting period. We've made some important first-in-human discoveries that it really is possible to map a relationship between what the mother has eaten just before conception and what her baby's epigenome looks like. Now, that epigenome is going to be controlling the expression of genes in that baby, and therefore having lifelong effects on health. So we're at a very exciting time. We've made some important discoveries, but understanding where that takes us forward is still going to take a long time. So I think we need to summarize it relatively simply for the moment, and with maybe the following, which is that we have very strong evidence that biology has designed something that can sense what the baby's conceived into, the environment of the mother's womb that it's conceived into, can record that information in the baby's epigenome, and then can recapitulate that to adapt the baby so that it's best suited to its future environment. So that's kind of where we are. Now, that's all well and good as long as the environment that the baby then lives in is the same as the one it was conceived in. Very often, particularly in Africa now, that's not true. So we have what we call a match-mismatch problem, that maybe the baby's later environment doesn't match what it was conceived in, and then its metabolic setting is at variance with what it sees later. And that's when we get the problems with obesity and metabolic disease. Now, the question you ask is about, well, can we do anything about that? I feel certain we can. I think the key nutrients are ones that we've probably known for a long time, which are related to the folate cycles, the B vitamins. So in terms of foods, we're really talking almost certainly about a lot of green leafy vegetables. So that's good news for nutritionists, because we've always been flying the flag of green leafy vegetables. It's going to be within that space that the interventions, I think, are going to be important, but perhaps with some additional ones in relation to choline and betaine, and even methionine, of course, which is an amino acid in protein, that may also be important in order to get that mixture just right for the optimal epigenome at the time when sperm meets egg and when the baby is conceived. So I think certainly the future will hold a lot of new things in terms of personalized nutrition. Now, for someone who works in global health like me, I'm obviously interested in it, but it's going to be many decades before personalized nutrition approaches would help people living in the rural economy of the Gambia. So I tend not to concentrate on that so much, but what we do work on is so-called stratified approaches. In other words, saying that not everybody is the same and we can target different groups of people. Those women who are having babies in the wet season as opposed to the dry season, for instance. So I think that's going to be tractable in a low-income setting. That's not to say that the personalized approaches aren't also going to be tractable for people in urban areas, the more sophisticated people living in Africa. And indeed, we're very interested in that in relation to the possibility that one can design really a tailored approach, for instance, in mums who have gestational diabetes or mums who have a tendency to be insulin resistant, and trying to stop that developing on to becoming full-blown diabetes. Now, what you've asked is, do our epigenetic signals help in that way. Not yet, but I'm sure they will do in the future.